In this video, we're going to talk about Contour 3D. Contour 3D can be found both in the 2-axis and 3-axis menus in SURFCAM. It allows you to drive a tool along a path through 3D space. In this example, we're going to drive a tool from the top of the spiral helix down to the bottom. To begin, I move to NC, down to 3-axis, and then down to Contour 3D. I'm going to chain the profile from the top, click on Done, and then our Contour 3D information appears. The first thing I'm going to do is change the tool from a flat end mill to a ball nose end mill. I'll choose a 375 4-flute ball for our operation. Click OK, and then we can move to cut control. The most important thing about Contour 3D is the cutting method. We have two choices, either on the contour or on top. With on the contour, the center of the tool will follow the path. With on top, the tip of the tool will follow the path. So if I want to drive the center of the ball nose end mill along the path, I'm going to choose on contour. Our curve tolerance of 1/1000 is typical. Rapid plane and plunge clearance are typical as well. Really don't need to do anything else here but click OK at the bottom and accept. If we look at the tool path in back plot and slow the feed down slightly, we'll be able to see the tool moving down the helix. If we look at this in a side view, you can see that the center of the ball is following the white helical path. We'll try it again with an on-top contour. To change our cutting method, we're going to go to the Operations Manager and regenerate the tool path with the original geometry. We'll move to the Cut Control tab and change the cutting method from on contour to on top. Then click OK at the bottom to regenerate. If we look at this in back plot, we'll be able to see the tip of the tool following the contour. I'm going to slow this down slightly so we can catch this, and we'll start. I'm going to switch to a front view now and continue the simulation, and you'll be able to see the tip of the tool following the curve. In this example, I'd like to show you a possible application of the Contour 3D tool path. I would like to drive a 750 ball nose end mill right down the middle between these two surfaces. To do this using Contour 3D, I'm going to go up to Create, down to Spline, choose Next, and then click on Cut or Intersect. Since I want to drive a 750 ball nose between these two surfaces, I'm going to have to select a 750 ball nose from my tool list. I'll click OK, and then we can look at the rest of the information. Here's our tool diameter, tip radius, and stock to leave. The final objective of creating the cutter intersection spline is to create a path that the center of a 750 ball nose end mill can follow. If we have 0 stock to leave, then the tip of the cutter will become tangent between the two surfaces as it drives along the path. If we give it additional stock to leave, the intersect spline will be adjusted to match that stock to leave amount. I'm going to click OK, and then it's asking me to select the first surface. I'll click the first surface, second surface, and then our spline is created. One thing to consider when creating cutter intersection splines is that the spline will appear on the side of the surfaces that the surface arrow is on. In the case of both of these surfaces, the surface arrow is on the outside of the surface, which caused the spline to be created on the outside of the surface. Our next step then is to go to NC, 3-axis, and then down to Contour 3D. We can chain the spline we've just created, click on Done, And then our tool selection will be the 750 diameter ball nose end mill that we used earlier. Going to click on Cut Control. We don't want to be on top, we want to be on the contour. That is, drive the center of the ball along the path we've just created. I'll click OK and Accept, and there's our tool path. If we go up to Backplot, choose this operation, click OK, and then slow it down, we should be able to see the tool follow the path.